Hi. So this project is going to be a fun one as we build a machine learning model that predicts if a Pokemon is legendary or not. Now Pokemon is very famous, and even if you haven't seen it, then you at least must have heard about it. So let's see in proper detail what we will be doing in this project. So the aim of this project is to find if a Pokemon is legendary or not. Well, on a serious note, this project aims to showcase the importance of feature engineering and understanding of the data. Now, lots of people already know about, Pokemons, the types of Pokemon, and many more info about it. But yet again, before we move forward, it is very crucial to understand if the data you have been given and the way you have interpreted matches and the way you have built the model also generalizes on that data. So the details of the project. Now the project is divided into three parts where the first is building a machine learning model and the second is building a web application where we can mount our prediction model and the last is deploying that web application on Heroku. So we will be using a Django backend or a Django application to build our web application. Now the first part is building a machine learning model. So we start off building a machine learning model and train that model using the Pokemon dataset. Here before we build a model, we understand about the data and all methods that can be applied to pre-process that data. Now Django web app, basically building a Django project. So this is the second part of the course where we will be using our Django framework and where we will be mounting our model, the prediction model into the Django project. Now the last part is deploying this Django application to Heroku. And we will be using connections to GitHub while deploying the Django application on Heroku. So now let's start off with the first part of the course, which is building our model in the next video. So this is the first part of the course where we will be building our machine learning model. The first part of the code that is telling you from google.collab import drive. So this is basically trying to connect the drive storage to your Google Colab so that Google Colab can access the drive. Next, as you can see, I have imported the necessary libraries which will help in data handling and data manipulation. Some of you might not know, but Seaborn is a library that complements or supports the matplotlib library, since both of them work well when we need to visualize the data. Now the next thing you can see is that I have called random forest classifier, that is our model, and to judge its accuracy, I'm using some metrics like accuracy score and classification report. Next, you can see I'm calling random forest classifier, and just to make one thing clear about random forest classifier is that this classifier overfits very easily on the data. So while we are training and testing, if we get a very high training accuracy, but a very low testing accuracy, that means that the model has overfit on the data. Well, I've also provided the link to the dataset as a backup in case you want to know where this dataset came from or if you want to understand more about the dataset. Now the first thing I'm doing is calling out the dataset and storing it in a variable named Pokemon data. Now you can see that I'm using the head function of my data frame to see the first five values in my dataset. And as you can see, it has a lot of columns and a lot of them are categorical columns, which I will talk about later. But from the info, you must have understood that which column is a target variable. As I talked about in the intro also, that our main purpose is to understand and predict which Pokemon is legendary. So from the data set you can see that is legendary column will be our target variable. Now moving on, from this point on we start with our exploratory data analysis and handling of null values. So first thing you can see is I'm using a isNull function and a sum function. This is basically telling me the sum of the number of time null value has occurred in each column. And as you can see, it is giving me 371, 77, 530 for the particular columns, and the rest are 0. Now use the shape function, which is telling me the cardinality of my data set. So it is telling me that there's 721 rows and 23 columns. So from the shape, it is clear that the data set is small and we can remove the null value columns. So why I'm directly removing and not filling the null value columns is because if I fill values that have 530 null values, it is meaning that more than half values I am filling, and it makes the data set a little biased, which is not favorable. So as I had mentioned before, type 2, egg group 2 and PR male have null values. And you can see that here, yeah, here you can see I'm removing those two columns, but I have specified three. So what I'm doing with the third column, you can see that for PR male, it had only 77 missing values. So 77 missing values is like 10% of my data. So I'm not directly removing that column, I'm filling there. So if there's too much of filling to be done, I'm removing it directly. If there's less filling to be done, then I'm filling it. So what am I filling it with? You can see here, I use the value counts function, and from there I'm able to understand that for PR mail column, I have this type of data and how many times they have occurred. So you can see that 0.5 is the mode for this column. So I'm filling it with the mode value itself. Next, I use the tail function, which is like the head function, but differs when it prints the last five value in my dataset and not the first. So this is the describe function that I have used. Now the describe is used to view some basic statistical details like percentile, mean, standard deviation, etc. So it basically summarizes for you all the integral data that you have in your data set. You can infer a lot from it, and one thing that I will like to point out is to look for max min ranges. You can see that a minimum is supported here and a max is supported here. So you can see the range for this number column is 720, or basically 721 to 1. Similarly for total, for HP and all of the integral columns. Now why I'm actually asking you to emphasize here is because if all the columns have similar ranges, then it's good. But if it doesn't have similar ranges, then you have to standardize your data or normalize some of the columns. Now standardizing the data is basically asking you to make a range in which all of the columns having all of their different values can fit in. And normalizing is basically changing your range, that is changing your max and min value. So there are different ways you can handle normalizing and standardizing, and a lot of different approaches have been made and are used in different situations. So for example, Let me just give you a simple example of how you can normalize your data. Let's say the range for one column was from 20 to 20,000. Now what you can do is use a, let's say, max min range where you're taking your value x and you're subtracting it with min value of your column, and say you're dividing it with max minus min. So let's say that there was a value x is equal to 300. So after normalizing, it changes to 300 minus 20 upon 19980. So it will turn to a very small value. So in this way, you can basically change your column or normalize your column to bring the ranges near to your other columns. Now we move forward and look at the correlation graph. So the next thing, which is this, is actually a visualization of correlation graph and all the integral values. You can see that there is the integral column or value holding column number, total, HP, attack, special defense, speed, generation, since generation is holding values from 1 to 6, and it has actually included the is legendary also, thinking that false and true are 1 and 0, and similarly other columns also. Now why I have actually implemented this has a very important actually has a very important reason, which is to understand from all of my data set which columns are actually useful to me, or which columns are actually useful in training the model. Now you can see that this correlation actually has a value of 1 as its maximum and value of -1 as its minimum. So it ranges from -1 to 1. And you can see the values are 0.98 for a generation and number column. There's a value of -0.64 for columns has gender and is legendary. So you can see that is legendary is a lot more dependent, inversely dependent in fact, with has gender. So you understand from your data set that you have some columns, and how many of those columns are directly or inversely dependent on your categorical column, or say how many of your columns are actually giving you the same information. Meaning, let's say for two columns that are total and attack. Now they are directly proportional, I would say, and have a correlation value of 0.7, which is very high. Meaning, if two columns have a positive correlation and a very high one at that, since 0.7 is somewhat close to 1, that means that total and my other, which was attack column, are actually in one way giving me the same information. Now, actually, this doesn't happen, but when the model starts to train and it takes in values from total and attack columns, so it thinks that, yeah, nearly same things have been provided to me, which is for this data set, it's not a problem since the dimensionality of this data set is small, only 23. But there might happen that you have a data set having, say, 100 columns, maybe 200 columns. Then you would like to remove at least one of these columns since they are very similar in nature, or the way they are affecting your target variable. So after that, we start off with handling our categorical columns or categorical data. Now, categorical data are like gems. They have a lot of hidden data in them. And if you're able to extract that data, your model would actually have a lot more predictive power as compared to before. So you can see that I have taken the type 1 column, and it has this many categories, which each occurring this many times. The next, you can see that I have done the same for generation, looking how many categories are present and how many times each category has occurred. Same for color, egg group 1, body style. And now comes another feature engineering part. Now this is one way of handling categorical data, and you would understand why I have used this or implemented this. Now I've used a function named replace, which is actually looking for these categories, water and ice, and then replacing it with this category. So basically, wherever replace function is looking at water or maybe having a value of ice in the column, it replaces it with water. Same I'm doing with grass bug, and you can see that here a lot of replacement has been done. So base now, you know, people who are really informative about Pokemon would say that, oh my god, what has he done? But this is important because after this, handling of categorical data, I'm going to extract data, meaning I'm going to maybe build new columns using this data. And then you would understand that why I'm trying to crunch all of these categories into a smaller range of categories. So now you can see that before we had a lot of categories, and now you can see that the number of categories has decreased, which was my motive. Now you can see that we have value counts function, which basically tells you how many times a category has occurred and all the unique categories specified. So I'm putting all of that data into a dictionary, and I'm using my map function, which is basically taking that dictionary and looking out for the keys. So if in my body style has a value which is present as key in my dictionary, so it will replace that key with the value itself. Now you might not have understood clearly what has happened. So later on I will show you what this part of the code has done. Now see, my body style has quadruped and bipedal tailed and many more categories in it. But my body style new column has integer values in them. So I know that 135 times quadruped has occurred in my column as a category. So I've replaced the quadruped category with the number of times it has occurred, which is 135. Similarly for bipedal tailed and all the other categories. So this is the encoding part, basically using my categories and building new columns or new part of the data set. So you can see that now, yeah. So you can see that a lot of new columns, body style new, drag, a dark dragon, electric, fighting, fire, and a lot more with colors also have been present here. Meaning now all of this was actually a category in one column which I've extracted, and now you can see that there's a lot of zeros and then suddenly a one has occurred and then a lot of zeros. So this is telling me that this Pokemon was actually a grass type Pokemon. So whichever type of Pokemon it was, it would present you with one there and the rest would be as zero. Similarly for color, here you can see that the color was actually green for this Pokemon. So one is present here and the rest are presented with zero. So next I'm just looking at all of the columns, the data which had the columns already and the new ones that I have made. All of them are specified here. And then I'm trying to draw the columns that are not needed now. So you can see that we started with 23 and have come up with 38 columns now. Okay, so before we dropped, we actually had 43, and after dropping, we have 38. So finally, we come to the part where our model is actually starting to get trained. So we are specifying our target variable, and after that we are using our train test split function, which is telling that have your data in the ratio of 8 is to 2, where 8 part would go into your training set and the 2 part would go to your testing set. Now I've called the random forest classifier and given an parameter of n estimators is equal to 500 and telling this class or maybe the object that you have to shuffle your data before you insert the data for training the model. Now use the fit function to train and use the predict function to uh, do the predictions for my test data set. Now you can see that there's a 100% accuracy for my training set and a 99.31% accuracy for my testing set. So you can see that both of my training and testing accuracies are very, very close, meaning that my data hasn't actually overfit or underfit and it has generalized well on the data set. Finally, what we will do is just save this data set or the weights of, save this weights of the model and use it directly to predict when we will be building our Django application. So you can see that I have saved the model to disk, and this code here is to how I will load the model from my disk. So now we will go to the second part, that is building a Django application. Now, this is the second part of the course where we will be building a web application using Django framework. Now, before we move forward, there are some steps to be followed, which you can see on the screen, and let's see those in detail. So the first thing that you have to do is just basically create a project directory. It can be anywhere on your computer or laptop. And after you have built the directory, build an environment. So if you're using a IDE like myself, so I'm using PyCharm, where you can just simply go to files in your settings, and once setting opens up, you can go to project interpreter. Now project interpreter is basically telling you that yeah, there's a already built environment, and that environment has all of these packages. Okay, so if you haven't built one, you can just click on here and there's an add button. You can click on add. So it's ask you to basically build a new environment here. So once you have built an environment, you can set all of the code, that is, my site having settings and all, basically all of the Django project inside your directory itself. Now go to the my site directory in your terminal. Like you can see that I have already built an project directory named src source, and from there I'm going to my site directory. So now in my site directory, you can see there's a manage.py file. So this is a very important file in Django, since most of the handling or creation of new app, handling of settings, maybe handling of databases, creating new databases, all of that has actually been implemented in manage.py. This is basically the command line where you could say that once I run this command, my Django project will have major changes done in it. So you can see there is also a requirement.txt file also. So first we will be using this. Now you have built an environment but it is empty. So you now download or install all of your dependencies and packages for this project using the command here, pip install -r requirements.txt. Now once you have done this, you can go back to your environment and see that all of the packages that I used while building this project have been installed there also in your environment. So once the environment has been set up, the code has been set up, you run these commands: python manage.py migrate and python manage.py run server. So this command basically is telling you to start on, or you should say create your databases that are required by this Django project. And once they have been created, fill them with specific data that is required. The second is python manage.py run server. This is asking the Django project to now run on a local server and render the pages. So since I've already done my python manage.py migrate, I would simply show you what happens when you run python manage.py run server. Python manage.py run server. So you once do this, it takes a little time to load, and now it's setting up this Django project locally, and you can see that it's performing system checks, and you can see that you have been given a URL here. Once you click on it, like I have, yeah, you can see that your page is rendered. I don't have to go at the quality of this page since I've just basically used the HTML and forms in it. But see that your page has been rendered now, and you can fill up with anything. Yeah, name of the Pokemon Siddharth. Yeah, I can keep my name. Yeah, cool. But anyways, you can now put data in here, and once all of that data has been filled in, you can just click on confirm submission. Now you have been able to set up the project. So let's understand the next thing, which is making some changes in your settings.py, and where actually the load, or you should say rendering of the pages, maybe handling of the data is done. So this is the views.py file inside your app folder, which is polls in my case. You can see that here a lot of files are present: views, URLs, models, and many more. So basically, you should focus on views and URLs and models. So first of all, models is the Python file where you are able to make custom tables for your databases to store value. Next, your URL is basically the place we are telling that, yeah, and this URL you're going to render this page. So you can see that in URLs you got yourself a path, you're calling a function, so these functions are in views, and you're giving it a name. So basically this line is telling me that on the path https, okay, http 127, basically local host, you're going to call this function. And if we go into views, my first function is, as you can see, rendering index.html. So from here it is able to understand to render the index.html, and you can see above that now I'm handling and pre-processing my data. Actually not pre-processing, just simply processing the data that has come to me from my forms. You can see that the index.html has forms in it, and from here the data that was input is now going to views, and you can see that there's a df, meaning I have already created a data frame where I'm going to store the data that I got from index.html. And then you can see I'm calling my pickled loaded model, which is Pokemon model. So it has weights that were defined when we trained our random forest classifier. And now you can see that I'm using the predict function to predict if the Pokemon is legendary or not from the data that I got from my forms. So this is the part. Yeah. Before we end this second part of the course, let me just give you a brief about what this finding type function is. You can see that a lot of zeros and ones. So you can see that I have in my first part used the categorical data to build new columns. Now, first we just had a column where we were defining the type of the Pokemon. Now I extracted it into different columns where I was putting zeros and ones. So here what I am doing is, if my type, which is coming as X, is dark, then return an array. This is actually a list. So return a list where the first value is 1 and the rest are 0. Now if you go here, you can see that for all the different types, I'm using this list to fill in the values using the zeros and ones. So there's a difference between your finding type function, actually finding type function, and your first function. See, the finding type is actually an helper function, and this function is not rendering anything. This is just taking in values and returning values. But your first function, which is taking an argument, sorry, a parameter, yeah, actually an argument as request, is actually rendering a page which is named index.html. So there are two types of function here at work. The first is actually rendering, processing the data. The second one is just processing the data. So if you are able to understand what we are doing in Vue, let's let's just go and hop on to settings.py. Okay, so this is the settings.py file. And if you have just built a new project, you would see that this is an empty list and you would see that there is a true here. Now understand this, whenever you're working in development mode, you can keep the debug as true. But once you shift to production, you have to keep that as false. It is already given a security warning. Don't run with debug turned on in production or when you're deploying basically. So since I've already deployed this code, I've changed the code for false and have inserted my allowed host. Now you must be thinking, where did this try one out.heroku app.com came from? So once we are deploying to Heroku, there's a page, specific page for an for our app where you could see this URL. So I've taken this from here and I would specify this in the third part of the course also. The next thing to understand is setting up our URLs for static files. Now understand this, that os.path.join is basically joining two paths, and we have to create this and specify this in the settings file before production, because Heroku is not able to understand how and where to actually put all the static files in. Since this code is basically asking Heroku that if there's any specific static files in my project, then just make a static files directory and inside that put all of that static thing. So static files are basically CSS, JavaScript, images. There are other type of static files also. You can just look at the doc here and you would understand more about static files. So once you have set up the settings also, you're good to go for production, which I will be covering in my third part. Now, since I've already done this, you can see it's already said that a Heroku Python build package is actually being used. The next thing you should do is click on this open app. Now, this might take a little time, and what I want to show you is that all of the files, or you should say templates, are going to be rendered using or clicking after this app. So once you click on open app, all of the files, templates that are present in your project are going to be rendered. So you can see that since the first template that I was rendering was index.html, it has rendered. But you can see one more thing, this URL. So this is the URL that I copied. Okay, so this is the URL that I copied and then set in my settings.py file. You can see here, these are the same thing. So one thing that I actually wanted to show you is that you already have to build an repository where you will be storing all of your code that is to be used by the server in your Heroku. So you can see that my site holes, that was my app with the static files, proc file, manage.py, requirement.txt and runtime are present here. Now once you are actually uploading the code, it might happen that there's no static files in your code. So if it is the case, then in your code, just write python manage.py collect static. If you run this code, then a new folder named collect static, named static files will be built here, and then you can upload the code to GitHub, like you can see here. So you can make changes here after you have, build a new app and use the open app button to go to that app. The next thing, after you have, made changes in your code and the final setup has been done, you go to deploy. Now deploy has three options: Heroku Git, GitHub, and container registry. Now we will be using GitHub actually, and you would be given an option of connect here. So once you click on it, it would ask you to log in with your credentials, and once you do that, it would tell you that yeah, it is connected to your account. Like my account is setp278, it has been connected here. Then it would ask you for the repository that it has to connect with, and once you type in the name of the repository, it would show something like this. So my Pokemon legendary repository is connected with this app in my Heroku. Now you're going to skip the automatic deploys because for that you have to build a CI, and the next thing is manual deploy. So you basically click on the branch, which branch you want to choose as your final code which the server will use. So since mine is master, I will just take the input master and then click on deploy branch. Now this might take some time again because now the server has to be set up with the code and all the dependencies have to be installed on the server itself. So you can see Heroku Python build pack is being used, and we specified our Python and version in our runtime.txt, which it has now installed. Sorry, oh my god, installed here. Okay, so next thing is it is installing all the dependencies from requirements, and once it has done that, it is using a command named collect static. So this command right here is now telling the server to build the new static files directory, and all of the static files that are present in my code are to be put there now. And if there's no problem or error shown, you would be seeing this URL present here. You can copy this URL, or maybe you can wait for some time, and okay, we will have to wait a little more. Mm, okay, so once it has done all the work, has set up the server, you would see there's a deploy to Heroku and a tick mark with it. So you can click on view, and again your page will be loaded. See, the page is loaded. Now you can just input your data and all, and then again confirm submission, and you would see the results. So with this, we end this course where we were actually trying to predict if a Pokemon is legendary or not, and have built a web application for it, and lastly have deployed it on Heroku. Thank you.